Okay, so as mentioned, I'm part of the, I was part of the TailF acquisition, so about 9 months into being part of Cisco, a big change from being a 63 people company to I think it's about 73,000. So it's a good opportunity to ask me really hard and fast questions and have me kind of reveal things that we shouldn't say now that we're part of Cisco, so have at it. Okay, so we're going to talk about a couple of things, and you're actually right. The theme here is actually to kind of actually share some of the observations that we have had over the last couple of years. And at this point in time, that's about as far as we can go. And just for some clarity and some framing, I represent what could be loosely called an NFV orchestration implementation. And people do ask us quite often, you know, do you have any good ideas, or what's your strategy on this, right? And the tone in most of these conversations you also hear from a behemoth like Cisco is that we'll be happy to share experiences, but you will have to talk to us and explain to us the way you think about these things, right? So this is more of an information or experience sharing session, right? And of course, I think we can all agree, especially the ones of you who's actually tried to do this, and I mean not look at the Etsy specifications, but actually build it, that this is a very fundamental challenge. And again, I want to stay away from trying to prove that this is important or something that will bring you immediate success or lower cost. That is for other sessions, and I can talk about that too. But what I'm going to talk about now, it is actually how hard it is to take the technology and move it forward towards where we want to go, right? And why, right? And of course, again, I am a vendor. I will want to share what we can do about these things. And you will find that what we can do will also span not only the company that is paying my salary right now, but what we as an industry can do about this. Current networks are super challenging, and this is kind of a level set slide that some of you may have seen more than once if you've seen me on stage. I just want to tell you guys that it's not that my customers that I talk to, I'm normally very North America centric, that they already have an 80% solution and they're turning to Cisco just to do that last 20%. They have about a 0% solution at this point. One of our customers have tasked us with trying to get rid of the Word application in their service provisioning chain, because at times their printed matter come out of order, and that is a huge problem for their delivery precision and time, okay? That is kind of the playing field that we're at. So we're trying to move away from all these manual steps, because what these manual steps actually do is that they drive an insane amount of integration costs. And if you listen to this particular company here, in 2013, you would hear that North American service providers spend on the order of $13 billion just keeping that last hop, you know, from your orchestration or OSS into the network alive, okay? And unfortunately for the industry, most of that is in professional services, right? Some of those things are professional services in-house, and very little of that is standard products. And this usually tells you something about the maturity of the market and the opportunity for commoditization or disruption. We're in the valleys, we can say disruption when we mean something else. And on top of this, because this is on current networks, we ram SDN into this, right? And I'm not making this up. This is right out of the ONF specifications. This is an SDN network. These are the moving parts. It's self-referential. It's a thing of beauty. But we're supposed to take this on in networks that are largely driven by Word applications, right? So we add the notions of controllers, and more importantly, we add the notion of applications running in these controllers. And who's going to actually develop and even more complicated, own these things. Own the applications that we develop on controllers is typically undecided yet, right? But it needs to make things faster and cheaper. And of course, the real world implementations I've seen are not, you know, they don't have, you know, all the services spanning or being contained into an SDN administrative domain. They always span the physical network and the SDN network. So you need something that covers both. And of course, as I'm saying here, you're talking about domain controllers and maybe even per data center controllers. So not only do you have this, you actually have layers of it. And of course, NFV really comes in for the killing blow, because now the complexity that we just saw in the SDN world is just a small part of one of the boxes in the big NFV picture, right? It's just supposed to be in there. So we add the notion of VNF life cycles in virtual infrastructure. And real networks, again, will combine the traditional networks with SDN controller-based networks. That is just a small moving part of an NFV-style network, right? So it's not taking us anywhere more comfortable. Actually, several of our experiences tells us that we're actually coming in on a breaking point. because we're actually adding so much complexity, and the complexity is inextricably linked, ironically enough, to the number of vendor components. And if you remember from the keynotes, of course, most ambitious NFV projects want to have a growing vendor base. They want proliferation of vendors, more agile, smaller startups and all that stuff. So many vendors is actually something that is desirable. It's just that with the number of vendor components, your implementation costs and your integration costs show a very scary shape, if you like, right? So what would the computer scientist do, or what would the engineer do? Well, we can reduce the number of vendors and interfaces, right? But that's boring. That's not what we do, especially not here, right? We try to actually build a multi-vendor virtualized network. Now, what would it take to attack the superlinearity, the shape of this curve, and actually try and see if we can smack it into something that actually makes more sense for us over time? Make it more scalable, if you like. Well, for starters, we've actually painted ourselves into a corner where we've been before, several times. So people who've been around have seen this happen before. We make things so complex and complicated. So we can do complexity, that's fine. Many of us have an engineering background. So actually, complexity is not that bad. It's when they are complicated, hard to grasp, and hard to program for, and hard to actually implement. That's where it gets expensive, right? And we forgot about this. When we built the architecture and the idea of doing this, we forgot about robust integrations because we skimped on details, right? If you look at specifications actually coming out of several standard-defining organizations around these things, you will find that they are very vague. You know, they don't really give you enough information for interoperability, for example, which is a good sign of the trap that I showed you on the previous slide, right? Of course, that plays right into that big ball of $13 billion. So that's going to be nice and round still. But if you want to change that, we have to do something about it. Let's look at some commonalities. And again, these are my observations. I'm more than happy to take violent disagreement from the room. Actually, that would be fun. Vendors have interfaces. This is just a general thing, right? All the assets that we send to you guys or stand up in your lab have interfaces, right? Many of them were invented a long time ago. There's a lot of relabeling going on in the market, right? So few of them are brand new, right? Many of them weren't really developed for this type of integration. They actually came out of another, set of usefulness that they used to do. And whatever openness they have are normally superficial. My absolute favorite is the term, let's just give it a REST interface. And for those who understand what REST is, you guys know that this is an architectural principle, right? It's not a protocol. It's certainly not a data model. It's not something you can actually interoperate. It's a way of thinking about encodings and communications, right? So having someone just say that, just stop them and call them out and say, what does that mean to you? Right? Give me more details. And it gets worse. So if you dive a little bit deeper, the interfaces that we provide actually lack all the structure and semantics that you would need as an integrator to actually have an idea of how much it will cost to integrate towards it. No details and no common semantics. Many of us vendors have a vastly different idea of the definition of a VLAN, right? Far above and beyond what the IEEE would say. And the protocols and interfaces, coming back to the REST thing, lack very basic features, things that developers would just assume. How do I undo what I just did? What do you mean undo? Do you think there's bugs in this? Which is actually a response I've gotten from a company that does OpenStack. Why would you need rollbacks? We don't have bugs. The only reason why you would need rollbacks is because if something breaks, and we'll just fix that bug then, right? And disagreement on layerings. This is one of my favorites, right? We are many vendors that are trying to kind of keep the way we do things. So one of the things that we'll see, and this is actually unfortunately for us, also reflected in, for example, the ETSI NFV specifications. You must use my EMS. Why? And just blank, right? Just use it. Okay, what does it provide to me that makes it more comfortable? You can't ask that, right? Just use my EMS. So there's a lot of commonalities around these things, right? And if we look at the details again, right? So interfaces lack common structure. Why don't we go for something that is well known, right? So now I'm stringing you along towards my solution. And I would like to see some janking of chains. You're doing a crap job this far, I'll tell you that. But, So they lack common structure and semantics. Why don't we go for a model-driven approach? Why don't we help people declare what these things are, right? Protocols and interfaces lack basic features. Why don't we use the domain-specific protocols that actually exists? And why don't we agree on them, right? Disagreement on layerings. Why don't we just open and standardize and make interoperable interfaces? The last word, in my mind, is the most important. Why don't we make them interoperable, right? That would be horrible for the integrators. That would shrink the ball. It would be great, right? Because you could actually have interoperable implementations. Here's my suggestion. No, actually, let's go through this first. There are three things that comes into play here, right? And people seem to have a hard time, making a difference between these three. Not this room, probably the other room over, but I'll tell you anyway. There's difference between configuration models and protocols. So again, we have things. We have software, we have hardware, there are things. Things can be physical routers, virtual networking functions, or controller applications. There's always configuration. Even the most forward-looking, SDN application has configuration, right? Persistent state that describes the behavior of that system. So there's configuration also in controller applications, right? The data model can be either explicit, so you have a schema for something that describes what the possible configurations are, or it can be implicit, which means that you have to guess a little bit. Actually, REST is the second. Very few people know that. You're not supposed to have a model. You're supposed to explore the model, which makes it half unusable for anything serious, right? So you have a data model, which is the set of constraints applied to the intended state, to the configuration, right? And you validate. So someone tries to change something in your configuration, the implementation checks, is this valid? Is this really an IP address? Is he allowed to add, interface IP address number 1025 to my Ethernet? No, he can only add 1024. Either explicit through a schema or through implementation. And then there's a protocol. Right? This protocol can be things like JSON over HTTP, leveraging HTTP verbs, what people mean when they say REST. Or it can be netconf, or it can be SNMP, or horrible CLI things that people type in, right? These are three distinctly different things. And we have a nice little language called Yang, right? Many of you might have heard about this, right? It's a formal data modeling language that is human readable and easy to learn. It actually comes out of the IETF. It provides you with hierarchical configuration data models. Fairly nice for this environment. Reusable types and groupings, formal constraints, configuration validation, and well-defined versioning rules. What it can do to you is it allows for a full and formal contract language between the thing and the consumer of that thing, independent of the protocol. So it's a declarative way to describe the model of a thing for someone to consume. And if you pair this with the netconf protocol, which is a domain-specific protocol intended for networking applications that makes a clear distinction between configuration and state, it actually provides a number of different data stores. It can give you change validations and configuration change transactions. It actually gives you the fundamental programming features for comfortable and robust automation of network services. That whole box usually says developers will like it because they don't have to care about the details, right? There might be arguments, and I was expecting people to say, that's an old protocol, let's look at some other protocols. Actually, this is less important. The declarative data modeling language that we had on the previous slide is more important. Now, this works, it exists, it is in fairly wide deployment. It gets a lot of interest from many of the standard defining organizations. I can comment from the IETF's point of view. Going into the most recent IETF meeting, we had 190 different Yang models coming in, mostly from the vendor base, for everything ranging from L3 VPNs to X733 alarms. So there's no doubt that there's a lot of buzz about this. We have Cable Lab stepping up. We have MEF just opened a working group for MEF services described in Yang. The ONF uses netconf and Yang for its OF config. There's tons of language bindings for the developers. Again, that's the target market. And there's tons of tooling, both open source, implementations of full controllers based on Yang, like Open Daylight, but also commercial implementations like from TailF and from UmaWorks, okay? And of course, the kind of catch-all here is that what about my favorite protocol? And this is just something I want to send you off with, or we're getting there, but kind of pre-send you off with, because of course you're going to hear from your vendor base, no, we think this protocol is much better, right? And talk to them, sit down and see what they mean. Again, just rest, don't let that over the bridge at all. Just call them out, but if they say something else, talk to them about how much does that particular protocol actually give you. How much of a clarity does that give you? Is there a transport protocol here, right? Is there an RPC mechanism? Are there well-defined operations? Is there actually a content schema language, right? So hold the protocols up that you get exposed to towards this, and so see how far up it goes. And if it actually covers this, talk about whether it's a standard, and talk about whether that standard process actually delivers interoperability, right? Just a good checklist if you're embarking on things or new protocols or new interfaces coming from your vendor base. Because what we want to do, again, just to wrap this up, right? I'm going to actually just scream through and just win the competition here, win the contest, is that we're going to take that ball, $13 billion ball, and this is coming from a vendor. We're going to make it smaller, but we're going to make the piece of the pie that is products much bigger, and we will leave the rest for the DevOps, for the actual engineers that builds these things, the people that are actually working inside of the context towards a particular problem, and have them drive the rest of the cost. And of course, there's a lot of ramifications to this, because if we allow ourselves to actually upset this and make it much less in need of integration, we can see this trickling up the stack. And what I'm personally more excited about, what does this mean? If we make this something that you can consume without enormous integration projects, what does this mean for the rest of the OS SPSS stack? And I'll be more than happy to be invited in about a year and tell you about my experiences from that, because this is what we see happening, is that it's disrupting or at least upsetting the OS SPSS stack.
Thank you very much. Do we have a couple of questions? Let me start with one. You made it also sound easy, but you also can apply this model both to legacy and to new.
Yes.
Greenfield,
Yeah.
which I think is the really unique capability you're talking about.
Yes. Yes.
So how do we apply models to make a legacy greenfield? Because this is one of the biggest problems. Is how do I bring the legacy environment into this work?
So you do two things. First of all, you grab the arm of the vendor and you put it really high up the back and say, we're going to try and live with what you have, but you're going to do this. You're going to change your behavior over time, right? And secondly, you constrain the problem, right? So you look at the APIs that you have today, and you apply technology to make it behave as close to something what we're talking about here as is possible, right? So, you're alluding to our products, right? And the way we do this, and of course, that is the approach that we've taken. We try to limit, let's say, the damage or the blast radius of these horrible APIs or vague descriptions into where they are, and not let them proliferate through the entire architecture. This will be good. I know. I see, on the inside, yes.
Okay, so I hear that the Yang is not really too friendly to OpenStack. Can you elaborate?
These are two synapses that I've never connected before. Okay. So let me take you on a journey. So OpenStack, if you look at the integration API, the way you integrate with OpenStack is largely through REST, right? Through their, in light of what I just said, their interpretation of REST.
Hold on.
Yeah.
Can I be more specific?
Yeah, go.
Today I'm not an expert. I'm just scratching the surface
Right.
here. So if you really look at the heat template or hub,
Yes. Yeah.
so you need perhaps a translator or something.
Right.
But Yang is supposed to speak or adapt to any language. Southbound, yeah?
Mm-hmm.
Because that's where you mentioned Open Daylight.
Right.
So Open Daylight, the northbound, you take whatever that you have through REST into Yang, and the Yang would do the magic, and then it translates into any southbound interface, like netconf is one of them.
Yes.
You can do BGPLS, you can do all other stuff.
Yes.
Now, when you go to OpenStack, you have the Neutron and Nuva and Kilometer and Rara. And if you are going to adapt the services that are offered by OpenStack into an environment that Yang is there, okay, now you elaborate how you make it happen.
Yes. Okay, good. So now I get it. I do get it. And let me just drop a bomb first. Cisco, we've actually written a white paper together with Alcatel-Lucent on the subject. No, I know. But we're just saying that we actually, there's a couple of us that have been thinking about this. So we think it's very important to make a difference between, well, for example, the heat templates you're talking about, and actually if you talk about NFV, the ETSG, there's a lot of talk about Tosca. You know, Tosca templates, right? Tosca, right? So in our mind, and again, this is in the white paper, feel free to argue, Tosca and heat templates are really good for what could be loosely called application lifecycle management. The way you stand up, patch, and let things run, and then you eventually destroy them. So it's a way of actually driving the life cycle of the application. It doesn't give you much in terms of how you configure that application. So in an extreme case, you would have let's say a VNF with a firewall that's actually an application, right? So you would use Tosca to fetch, install, and start the firewall. But we would suggest thinking about Yang to describe the configuration API for the firewall behavior. So we think they're very complementary, and that they have totally different purposes. Tosca has a very, let's say, procedural lifecycle idea to it, while Yang is declarative, and you act on the instance. And they're very complementary, very nicely. And the corollary of that is that don't try to use Yang to replace Tosca, and certainly do not use Tosca to try and replace Yang.
I don't want to be the only one that's talking from this side. But
Yeah.
I have a more practical question regarding, say, if we have several different vendors implementation for the same VNF, like the firewall, do you expect them to expose same young description of what they provide in terms of configuration, or it would be different ones? I'm thinking about replacing one VNF with another implementation. How do you think it would be possible to do?
As a piece of history, the only reason why we were allowed to do Yang in the IETF and not get shot down by the vendors was when if we promised to do very ambitious extensibility models. So what I'm suggesting will happen during our lifetime is that there will be basic firewall functions expressed in industry standard Yang modules that will then be augmented, extended, and decorated by the vendors. And that's going to also happen in the services layer, actually. And that's just, without that, we wouldn't have gotten off the ground.
Another question? What is that?
So augmented, does that equal proprietary? And if it equals proprietary, then isn't that just kind of where we are already? With, 3GPP SA5 as a northbound interface from the EMS they've been working on for 100 sessions. They've recently had their 100th meeting, and they meet 3 or 4 times a year, so you can figure out how many years that is. And it's 70% proprietary and 30% standardized.
Yeah.
So, and
Yeah. No, absolutely great question. So what you're alluding to is frankly not a technology problem. It's kind of a behavioral problem from the vendor base. They will be I gotta switch. We will extend things that will make us different enough from others that interoperability will suffer if we do it badly. The way we actually structure the Yang language is that if you have let's say in the IETF, we now have interface configuration, IP configuration, static routing, and for example, ACLs, or access control lists, right? And as long as they are around and the devices, what's called announce support for them, the operations should work the same, independent of whether there are augmentations or extensions. So the basic operations should behave exactly the same across, right? Until you touch these augmentations or extensions, right? So there's a certain modularity here, but it can be bent. And yes, we have we have another shot at trying to do better by vendor management, by managing us and expecting things and showing up and paying attention to the standardization processes, and use, again, coming back to one of my first slides, fostering and requiring interoperability. Scream it.
I just have a question, a short question. Is not the value of, I mean, I do understand very well Young as a value, but one of the value which I see also is to generate automate code. Like if you see, for example, ODL, right? It's 80%, 1.2 million of licenses, but 80% is automated generated because you have the Young model and you generate automated code. And this also can answer to the previous question because, yeah, you can have proprietary things, but you generate automated code, and then in some way you ease the pressure on the interlock between service provider and vendor.
Yeah, I think what I picked up from that is that the fact that it's declarative and it's a contract language, a detail, you can actually generate code. And I'll add more to that. You can generate test harnesses. You can generate builds. You can generate documentation. You can, there's so many things, and this plays right into, again, the DevOps or the development culture where we want to go.
Please thank Carl for really doing the stuff.